This is the workbook page is this even numbers and the review problems in the back. I hope you finished number 2 on here. That would help. I think did I check it? Yeah, I think I did in class. Okay, but the last page I wanted you to answer these questions also. All of these right here. Alrighty, let's see. Some of you I notice is still struggling with this. I need to go over it in class. Make sure that people understand it. These question A, B, and C. Okay, let's go number 2 here. Analyze the graph between 2 and 2.5 hours. Where's 2 and 2.5 hours? 2 and 2.5 is this little spot right here. Analyze that graph. How far has Greg traveled between 2 to 2.5 hours? 0 miles. He traveled nowhere. 0 miles. How fast was he traveling during this time? 0 miles per hour. He's not moving. Greg is not driving. He may take a coffee break or something. He may take a coffee break. Explain your reasoning. That's important. You need to explain why he's not driving. Describe the shape of a graph between 0. Let's describe that. That's called a horizontal line. So it is neither positive nor negative. It's linear. It's called horizontal. It's neither positive nor negative or negative. It is continuous because it's one line. And positive, continuous, and what other word? It's linear. It's horizontal. We call that a horizontal. Horizontal line. It's horizontal line. Okay? Did number 5. Did I number it all wrong? Oh yeah, I numbered it all wrong. All right. Oh. Number 5. Analyze the graph between 5.5 and 8 hours. 5.5 and 8 hours. 5.5 to 8 hours. So right here, analyze this graph right here. Okay, just right there. Let me draw it better. Just that little line. Analyze that graph. Okay, how far from home? Oh, this is from home. How far from home was Greg after driving 8 hours? Okay, how far from home after 8 hours? Actually, he's getting closer to home. He's 130 miles away from home. So he's probably going home. Greg is is 130 miles from home. B, describe the graph, okay, describe that graph. It is, if you write your name on it, Wilcox. It's going down. So it's a linear graph decreasing. It's a linear graph that is decreasing. Linear, decreasing. And it is it discrete or continuous? It's continuous. And continuous. I don't know how to continue this. I believe that's how it's spelled. I need to check it. Okay. All right. This is something I need to go over tomorrow. Okay, again, in class. We do not make this improper. We make this equal to 0. So 46 and 4 over 5. We need a minus 46 and 4 over 5 plus that r equals to 4 and 1/10 minus 46 and 4 over 5. There's 0 there. You got r equals, common denominator is 10. Okay, that's a 1. And I'm going to write it this way. Because this one is a bigger number, I'm going to write that on top. Negative 46 and 4/5 minus plus a 4 and 1/10. We're going to do it that way. Bigger one always goes on top. R equals negative 46, denominator's 10. So times 2 times 2, that is 8 plus 4 and 1 over 10. We subtract because one is negative and the other is positive. So we get a negative 42. 8 minus 1 is 7 over 10. That's my answer for R. Multiplying, this is a multiplication problem. You need to make sure all numbers are improper. Okay, we need to multiply on the very side by its reciprocal, 3 over 2. You have z equals, cross cancel, you can't. So we have 27 over 4, or 4 into 27, how many times? 6, 7. 6 is 24 with a remainder of 3 over 4. It's multiplying, so we need to make sure every number is improper. Multiply by its reciprocal on the variable side, 10 over 3. Cross cancel. C equal, cross cancel. 4 over 1 or just 4? Okay. Oh, Least common denominator we don't need. Okay, how do you solve problem B and C using the following improper fraction? Okay, first, because it's a multiplication problem, you need to make all numbers into improper fraction. Because it's a multiplication problem, all numbers need to be improper. Then multiply then multiply the problem with the reciprocal of the number attached to the variable. This number is called a coefficient. Okay, and that's it. For the worksheet.